Alright, it looks like I'm streaming again. I am feeling pretty good about what I want to work on today. Working a little bit more on some 3D tools for my document rendering library, and that's my plan for the day. I've got a few things in mind related to what I just finished off working on yesterday, which was kind of a rendering of a circle and the extrusion of a circle. I had a few ideas about that, and I have a few little things I want to just kind of work on casually today. As is usual with my stream, it's not necessarily about being hyper productive the whole time. It's a little bit about casually approaching my programming and prototyping, which is what this is. This is totally prototype work, and just having a bit of fun, trying stuff out, talking about it, troubleshooting, mulling things over as I go. I'm not a perfect programmer, but that's not the point of the show. It's just about learning, having fun, relaxing, all of those things kind of muddled together. So to get into it, I've got here my pretty usual setup. On the right here I have the render of the document I'm working on. It's getting really messy because I've just been plunking in sections to test out different functionality. So yesterday I made this CAD view thing and this crappy circle function, which I'm testing out right here. So the document itself is getting a little messy, and one of these days soon I'm gonna finish editing it and actually have a finalized design for this little standing desk that I'm gonna build, because that's still, of course, one of the outputs I want to actually have from this, right? I can't spin my wheels forever on messing around with library code. I need to actually produce the thing I want to produce, which is a nice, cool looking document that has CAD files in it, basically. So there's work to do, right? But today I got my future blog notes thing here, and up in this corner here I have my sort of rough to-do list for the day. So I have a circle function I want to finish. I have a regular polygon function I want to do, and I also want to, if there's time, I want to work on this here, Multipath Sketches. So what I mean by that is, in the 2D context, I want to be able to draw a polygon of whatever shape, and then inside that polygon draw other closed path polygons that are then that are not part of the shape itself. So you can imagine something like, what's a good example? Well, okay, if you draw a donut, a top view of a donut, right? It's a circle, and then on the inside it's another circle, but only the ring itself is part of the shape, right? The innermost circle is outside of the shape. So as it is right now, my polygon tool here, this function polygon 2D, only accepts a single list of points and assumes by default that it's a convex closed polygon with no holes in it at all. So if there's time and a reasonable approach that I can think of to handle it, I want to add this ability in there. And the reason I want to do these things, well, first of all, the circle and regular polygon functions I want to use because I want to be able to draw a 3D model of a bolt and a nut, because for my design I might want to have the option to fasten things with a bolt and nut feature instead of, say, wood glue, for example. So the simplest rendering you can do of a bolt is a cylindrical extrusion and then a hexagon extrusion on top of it. So that's the very practical reason I have for wanting to do these, make a circle function and then a regular polygon function, because then I can extrude them and make a nice 3D shape. At least that's the theory. And then this here, to allow multipath sketches, is because I want to do, for this design, I have this kind of idea in my head about kind of a cooler looking leg piece that looks something like this bad sketch that I'm sketching out on my paper here, which you can see in a moment. It's something, it's stylized and it's kind of goofy, but it would be kind of cool if I could draw. Let me switch my camera for a moment. You know, like if the leg itself had these like triangle cutouts through it, right? So it looks like a truss or something. That would be kind of a fun design. Obviously, you could make it look way cooler than that, but it requires, this would be the face and this is not the face here, right? So it requires the ability to make polygon shapes or sketches, 2D sketches that are, that can have those interior edges assigned to them. So that's the idea. I need those kind of functions to be able to continue with the design that I'm working on, so it makes sense to add them in. So on that note, I have, pardon me, as a bit of a refresher here, I have this crappy circle function which draws 8 points evenly spaced around, and that works kind of, but I actually have some interesting different approaches that I could take for that one, which I'm going to show in just a moment. But to get myself on track here, I'm actually going to split this out into its own heading section so that circles, so I've got the extrude function, I've got circles, which is exactly fine. Yeah, okay, that's good. So let me come back up here for a moment. Oh, by the way, this pane at the very top here where my cursor is kind of rolling around is the document that's being rendered. That's this whole thing here. So when I change this and save it, I have a background process that re-renders this, and then the server refreshes the view for me. So pretty simple, but it should work. So if I make the radius of this 2 instead, wait for it to rebuild, I should see, if things are still working, which they should be, that this circle increases in size here, and then this cylinder, so-called, also expands in size. But I have to first see if it's actually going to work the way I think. So there's an error related to something I think I changed yesterday, which I should now fix in the builder. Here I've got, okay. I'm in org mode, so files, when I change things, sometimes I forget to specify where the code blocks get saved into the source code. So that's a tangent that I don't need to go down at the moment. But that should fix the problem, which is fine, but then I have to rebuild. There we go. Okay, so we're on track. Things are looking okay. So I called this function crappy circle because obviously it's not really drawing a circle. It's drawing just a polygon. Now, for the sake of simplicity in rendering a wireframe, I am going to I'm still going to use a faceted shape. So what that means is the circle, the curve that the circle is, I'm still going to render with sets of straight lines. Just for the sake of the wireframe of an extruded circle is a wireframe of a cylinder, and a pure cylinder has a curved side face. And for right now, it's just easier to depict the extruded, a curved face as the faceted approach. It's just way more straightforward, and it'll work just fine for what I need at the moment. So I'm going to use a technique like this, but I'm going to go about it a little bit differently. So to get in there, I may as well start up get back to what I was talking about here. So I'm going to use the idea of parametric equations. So what I can do with that is I can make a function, parametric circle, that takes a radius. And then what it's going to do actually is return a new function. So this is a higher order, I run a function that returns its own function, which is useful. It's a really powerful thing that I can do in Clojure. And other functional languages can do it too, I suppose. But what you can do is have a function of R that returns a function of t. So let's imagine that for some reason I want this function to return R times t. Okay, so if I run this, if I build that if I move it over, and it's defined in the REPL now, if I use that parametric circle and I give it a radius of 5, so it returned a function. So what I can do is call that function, use it, and let's imagine the parameter t I give it is 0.5. So I'm basically here, I'm building a function and then calling that function that's built with its own argument here. So because this is just radius times t as an example, the result that will come out of this is 2.5, which is exactly what you see here. So using that idea, I can very quickly create circle functions that will, instead of returning just a number here, what I want to do is, for some value t, return a point, so an xy point. And the reason I want to do that is I want to actually make a function that is the parameterized version of the line, like the edge all around a circle. Okay? So what I'm doing is using, so if I actually, I've searched this already, parametric equation of circle. This is a mathematical way to define equations of circles here. Parametric equation of a circle is pretty straightforward. It's the locus of all points that satisfy these equations. It's a set of two equations. Given t, x position is r times cos t, and the y position is r times sine t, which is pretty straightforward if you remember the trigonometry of it all. So it's very simple. So what I want to do is take that idea and put it into my code here. So which is pretty easy as it turns out. So I can just do a let here. So I know actually all I need is an x and a y out of this whole thing, right? And then x has to be defined in some way as a function of t, and should use r because r is a parameter I put in when I'm building the function, right? So if I just follow this exactly here, it's very straightforward. All I have to do is multiply the radius here by cosine of, let me call it properly here, math / cosine of t. And then very similarly, y is just going to be r times math / sine of t. And then the function itself just has to return x, y in that sort of form. So if I now build this, what we know about circles is that a full rotation around is 360 degrees, but it's often way more useful to use radians. So a full rotation around a circle is 2 pi radians. So that would mean that the default t parameter that's expected is anything between 0 and 2 pi. And technically you can supply it anything. You can supply negative values, you can supply values greater than 2 pi, but because it's a circle, right, it'll just start returning the same point values. So you only need it to go from 0 to 2 pi. But I also want to make it one step. Well, so before I get anywhere, let me build a function here. Let me define circ as parametric circle with a radius of 2, because why not? There's no reason not to. So now circle, this is a function, so I can pass circ an argument t. If I give it 0, it should be starting at this particular point. If I use this as an example, right here, right on the x-axis. So we should see it return for me 2, 0 as a point, which is exactly what I see, which is really nice. So now if I pass it pi, right, since pi is full rotation around here, I should see -2, 0. So let's try that. Math pi. So I have -2, and I have this isn't 0, but because I'm messing around with floating point stuff, it's going to give me weird values. It's 2.45 times e to the -16, which is, I'm an engineer, I'm going to just call it close enough that it's 0. So for the sake of laziness and simplicity right now, I'm not going to build in something that worries about rounding those things to zeros. Because I'm not sure that that's as easy as it might seem. Let's just see what happens if I put round on those anyway. I did something incorrect. Math, round. Yep. Well, maybe the symbol doesn't exist. Okay. One last thing to try. Math dot round maybe. Point being, rounding and floating point errors and all of that stuff is very important, but I'm not exactly going to worry about it right now because I'm not doing anything that requires critical accuracy, and I'm also not at the moment comparing two small or two very large floating point values for equality. As soon as you're trying to compare floats for equality, then you really should pay attention to that stuff. But that's not what I'm working on today, so I'm going to be pretty much fine with it. But so this parametric circle works pretty well, right? It takes values from 0 to 2 pi, and if I, in fact, let me do half pi, so I should see 0x to y, just to finish up a manual test here. If I do pi divided by 2, yeah, so we get the same sort of thing here. We got 1.2 times e to the negative 16, so effectively 0, and 2, which is nice. Okay, so that's working the way I expect it to. But one thing I would rather do is just have t, the value that I'm parameterizing by, just for simplicity, be a mapping from 0 to 1 as opposed to 0 to 2 pi. So what I can do there is just do this. If I define t as the multiplication of t times math/pi here, I don't need to put that bracket in there. So now I'm just, in the context of here, I've just redefined t to be t times pi there. So that just means now all I have to do to get the same results here, instead of math divided by pi divided by 2, all I have to do is 0.25, which is a quarter of the way around the path of the circle. Oh, I have in fact made one mistake. This is wrong here. This has to be 2 times math times pi, 2 pi times t. So that should in fact work. And of course I have to redefine circle, because what I've done is redefine the parametric circle, but circle itself was built from the old function, so I have to redefine it. So I have to do def circ as parametric circle of radius 2. Now if I do circ 0.25, I should see 0x to y, which is exactly what I see here. Okay, so now just a final, if I do circ 0, I've got 2, 0. If I do circ 1, since it's looped all the way around once, I should see the same point. And we have a floating point related problem here, but I'm calling it good for today because that's basically 0. So I have the ability to make circles using parametric functions now, but the problem is I have no way to conveniently draw them out. So, but I do have an approach that will work quite nicely for that. So I've got crappy circle here, I've got parametric circle. I'm going to combine the ideas of these two things and make a circle function that I can use in my SVG drawings, which I can use to make nicer circles here. Since the shape of things is still, what's an example? Let me do, well, let me see here. Crappy circle with radius 1 has the shape, it's a list, or pardon me, it is a map that has 3 keys, nodes. Oh man, it's a little hard to read. Yeah, so it's got a list of nodes, a list of edges, and a list of faces. And since it's 2D, it'll always only, well, for right now, it'll only have one face, which is fine. But the parametric circle returns a function. It doesn't return a list of values, right? So I have to make circle return a list of points like that, which is fairly easy to do. It's going to be almost the same as this. So if I define a circle, I do want to provide a radius here, and then I want to do let circle circle function, may as well call it that. Circle function is going to be parametric circle of the radius that's passed in there. Then actually all I need to do is use that parametric function to produce for me a list of points, and that's actually very straightforward. All I need to do is well, I can just show it here. So that's the circle function, and the result of this circle is going to produce a polygon 2D from map V, where I'm mapping range, well, pardon me, I'm mapping the circle function, which takes one argument of t, onto the range from 0 to 1 with a step of, well, let's say I want I want 10 edges, so I just make the step 0.1, which, let me double check in here, range 0, 1, 0.1 will give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that correct? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this range, would it have to be like that? Let me no, this is too much. I don't need that. Well, okay, let's stick with this as a starting point. The range itself I might manipulate around, but the point is that this will theoretically, if I do map circ onto range 0, 1 of a step of 0.1, that does in fact return a list of points, which I don't need to map V that actually, which should work through Polygon 2D exactly the way I want it to, and circle should now work automatically. So if I do circle 2, it does indeed produce, oh no, something's a little off here. No, it's good. Okay, we're on the right track. Let me run crappy circle. Nodes, edges, faces, and then if I run circle, okay, I think it's working, but it's printing the wrong, it's not printing to the REPL correctly. Let's try edges of circle 2. Does that, yeah. And then let's try faces of circle 2. Okay, so It's working, it just, when you print it to the REPL, it is choking a little bit, but we'll call that okay for now. So let me now try this. Instead of calling with crappy circle, let me define this cylinder with a regular circle, and I will see if it correctly updates here. There might be an error. Unable to resolve symbol circle in this context. And the reason for that, because I didn't tangle this code back into the source, but it should work now. Let's try that, and we shall see in just a moment. Hey, there we go. That is looking pretty great. So let's increase the resolution of the circle a little bit here. I want to instead do double the amount here for a minute. So if I save that and save the change in the document to force a rebuild, I should expect, yes, see that? So that is looking pretty good as circles go. That's starting to actually look like one. And as cylinders go, that's a pretty good rendering of an extruded cylinder, in my opinion. I think that's pretty cool. So I want to, this is just a brief aside. I want to see what, if I change the CAD view, this isometric one here, if I instead draw faces, will I break it or will it be fine? I don't know. Oh, I have to do this, of course. I hope everyone's having a good day, by the way. If you have questions or just want to chat, feel free to go ahead and chat. I'm working on my code, but it's always fun to answer some questions, just have these little sidebar conversations. Feel free if you're into that sort of thing. Okay, so I've got a little problem here. Draw faces null. Trying to be lazy here. Draw edges, recursive. Let's just go back to that. I can fix this. Well, I can change this by doing figure. If I do 500, 300, scale 20. Cylinder. Like that. No, actually like this. Draw faces, cylinder. That should render another thing down here that lets me see just the one instead of all three or all four views right away, in theory. No, I still did something wrong. Well, let's try that. There we go. You got something there. But orient ISO. There we go. Okay. Okay, we're on the right track here. Move this shape 5, 5. Let's try that. So this is exposing, oops, save that, a weakness in my implementation for draw faces. I've got Z ordering issues here, right? So what I would expect in a properly rendered situation is this inner curved edge, like this curved edge here, would not be visible, and only the it's confusing because things are not ordered properly, right? So I have some of the back faces are rendering in front of the front faces, which is no good. But right now I had just I don't want to do anything to fix that at the moment, because I only really need a wireframe, right? So if I'm just going through manually and just deleting the faces that are in the wrong spot so that it at least looks correct. Oh, I deleted the wrong face there. Point is, the faces don't render in the right order, and I have no logic of like backface culling, so the document gets big when there are a lot of faces, because they're all technically being rendered into the document, even if you don't end up seeing them all. But this is a known issue like that. That's not surprising to me. I knew that that was true of my implementation. But what is exciting is that the circle function is working in a pretty nice manner, if you ask me, which I'm happy with. Let me go back here and just remove this figure here like that, save that, and be right back. Need to go grab a drink of water. Let's see here. got some water and a little bit of coffee, and I overfilled my overfilled my mug a little bit. That's my bad. Got greedy. All right, where was I? I'm wondering how many faces I really should, or how many edges on a circle I should have as like a default. If I go here, draw, where was I doing it actually? Circles. Right, the thing that dictates that is actually the step that I take in the range here. Right, if I cut this in half again, it's going to make even more faces in the cylinder, which might look good but be kind of devastating in terms of file size. I mean, that looks pretty nice. Looks a little chunky here. Let's see. Right, and it like this is gonna have a ton of polylines in it, which is not, see that? It's made up of a lot of different polylines, which is not good on file size, nor probably not good on like rendering efficiency either when you open it up in the browser. So there is room to improve the method, the method I'm using here. But I'll see how I deal with that. I'll cross that bridge when I get to it. One initial thought that does come to mind is have a step like during writing of the document you can use SVG, but when you export it to its final view you could potentially have an option or something that it renders all SVG spots to a PNG image, and then either embeds them or puts them in a resource file, which might totally decrease the total file size of everything dramatically, but then you lose the benefits of SVG. So that's the first thought only. There's probably better approaches. Let me check one thing though. If I do draw and I check my draw function here, I'm using draw edges, and I have 4 edge and edges. Draw a line. So that's why I'm seeing a bunch of polylines. What might make more sense is for face and faces, create a polyline using the list of points that's from the edges. So let me put a little note there. Maybe important to convert draw edges to start to use polygon for each face rather than polyline for each edge. May keep number of DOM nodes down. Pardon me. Right, so the reason I write that for myself is because this function, I'm drawing a line between every single point as opposed to using the list of points to make one polygon. I'm making just a ton of lines in there. So, room to improve. How's everybody doing today, by the way? Feel free to chime in the chat if you're interested, or just sit by and watch. I'm cool with that too. I'm just glad, just hoping everyone's having a good time, you know? Oh boy, zoom, zoom, zoom. Okay. There. Okay, so I have a circle function, which works fairly nicely, in my opinion. It's pretty cool. I'm just thinking, I just have this little, this is just a curiosity. Before I move on, I want to try I don't know if oval is the correct term, but R and A is going to be the factor R coefficient and stretch. Let's call it that. And I would need to make a, I don't know if this is going to work, but it's fun to just try it for a moment. Parametric oval R stretch, and then it produces a let's call it, let's stretch it along X with R stretch there. So if I do that and do that, if I def cylinder X oval is oval, oval 2 and the stretch factor of 2, is that going to work? Let me see what happens. First off, I didn't tangle the code in. Now if I do this, let me see if my brain's working. It's not totally working because I haven't changed this function yet. I have to do oval function here is parametric oval, not parametric circle, right? And then instead of circle function here, it's oval function. Save that. Save this. Now, let's see if it'll work. I expect it to stretch along the X like this, if it works. Might not. Wrong number of arguments passed to parametric oval. Of course, there. Do that, save this. Let's see if it works. Didn't I save it? I thought I did. Parametric oval, right, takes an R value and a stretch value, which I have here, and then I called oval up here with that, so I think it's working, and I just am not saving things properly. There we go. Cool. So I get a weird oval scenario kind of for free, which is nice. There's probably a smarter way to do it instead of like a stretch value. Like it might make more sense to do like the poles of it, right? So you have a point here and a point here. You have, well, let's see, parametric equation of an oval. Let's see what they're, an ellipse is the proper, an ellipse is the word I should be looking for. Oh, okay, so no, this is exactly, it's the locus of all points to satisfy these equations. So what I would have to give it, A and B are the radius on the x-axis and the y-axis. Okay, so it's close-ish to what I had in mind. I've just defined A as B times some value, which is what I have here, right? So B sine t is in this case R sine t, and then instead of A sine t I have B times stretch. Okay, so that kind of makes sense. Centered at the origin, not centered at the origin, that's sensible. Yeah, so it's a perfectly valid ellipse. I'm just defining, I'm just using a different parameter, or pardon me, like I'm just kind of defining it a little differently there. So what would make more sense to be more equivalent to this is parametric ellipse, and then I would have Rx, Ry, and then the only difference here, x uses Rx, y uses Ry. Oop, I did something wrong here. I did not get rid of the stretch there. That should work. And then here in the oval function, I don't call it oval, I call it ellipse. And I do Rx, Ry, Rx, Ry, and then ellipse function is parametric ellipse, and I call it with Rx, Ry, and then it's ellipse function, and it should be basically exactly the same at this point. And let me just split that off because it is its own thing here. Ellipse, parametric ellipse, ellipse seems accurate to me, and let me save that. And here I can just do ellipse. So now if I were to call this, so what I need is 2 by, let me do 1 by 3 just to mix it up a little bit there. And I'll only extrude it by 4 just to sanity check that things are changing. So if I save this and I haven't made a mistake, then this should shrink down a bit and have slightly different proportions, but still work. Okay, there we go. The only issue I have is, no, that's exactly right. Okay, cool. So I actually got kind of a function almost for free. Circle, ellipse. So crappy circle I can actually get rid of now because I just don't need it. So this as a general idea for some 2D based, or for some useful drawing functions in the 2D context, it's kind of a good, or it's a helpful idea that I might use more and more, to have whatever shape I can be first parametric, and then use the parametric thing to define a sort of discretized renderable version of it, right? So that's exactly what this is here. So it seems like a pretty useful approach, and I have that parameterized circle as a starting point here. I'm going to use this to make a bit of a blog post about it, because that seems like a pretty useful kind of approach, and it's not too difficult. So now though, the next thing I want to work on is, since I've done the circle function, I even have an ellipse function, circle function slash, well, and ellipse function. I want to now make a function that will draw a regular polygon for me. So to do that, let me go split and make a new set of a new spot to write some code. So I've got circle, ellipse, regular, polygon. Right, so regular polygon is something that I want to, it's like a hexagon or an octagon. They all, for at least how I'm using the term regular polygon, it's a closed thing with straight edges, all of the side lengths being equal for n sides. So if I define regular polygon, what I want two parameters. I want the radius of the circle that you can draw all the way around it, so the outermost circle that you can that hits all the vertices of the thing, and the number of sides n. So what I know, I have a little note that I prepared here as well. So a regular polygon with this is fairly straightforward, because I know every vertex of the polygon is going to be the radius distance away from the origin point, and then the angle that's separating each vertex is just going to be 2 pi divided by the number of sides that you've got. So am I looking at the right spot here? Regular polygons. Yeah, here. I've got a polygon thing kind of already defined here. So if I use that simple idea, I can make an angle function here. Angle is just going to be math/pi times to n. So this is equivalent to, if I do 2 times pi times 1 over n, which maybe I'll leave it that way because it's a little clearer to read. And then all I need to do is make a little for thing here that has a delta, which is the 0th point has an angle of 0, the next one has an angle of 1 times angle, then 2 times angle, then 3 times angle. So delta's not right. Let's actually do step. range 0 to n should work. And then here, all I have to do is return a point. So it's going to be some x value and some y value. And the x and y values are each going to be the radius times math cos and then math sine, respectively, times step angle, like that. And likewise here, math sine, step angle. And that should work. Let me see. If I do a regular, if I call that regular polygon with, let's do radius 2 and 6 sides, it should give me a list of how many points? 1, 2, 3, 4, 5, 6 points. So I have 1, 2, 3, 4, 5, 6 points. And do the numbers make sense? The first point will be without any angle to it, so I'm going to have the radius and 0, which makes sense. This makes sense to me as well because the top edge will have the same y values, which are both visible here. This is exactly opposite, so negative 2x and 0, close to 0 in the y. And then likewise here, we've got the same values in the opposite. Okay, that looks like it should be good. Okay, so let's make a little drawing here. Let's do here, define x hexagon. Let's rotate it the same I've done here, extrude regular polygon 2, 6. And I want to extrude it for, let's extrude it 5 for fun. And 90, 90, 0, just so it looks cleaner on the camera a little bit. And we'll do x hex. Okay, let's see if that works. Let me see. It would appear I have a problem. Classic. Well, why is that now? That's strange to me. I'm confused as to why that would be. Let me see if I've done everything correctly in this function here. That looks right. That looks correct. Yeah. For let defin. What have I done? Okay, let me see here. Let's look through the file itself. Okay. Unmatched delimiter in the builder thing. That I've not seen that error before. That's why I'm a little confused by it. That's all. Because I don't think I changed anything unless I typoed accidentally somewhere. Shoot. It's a shame when that stuff happens. Okay, let's open the file. We'll do it in VS Code because I've got enough windows and files open in my Emacs already. And this is just a quick little look-see. Source, builder, open, line 136 is right here. Okay, so I've got a parsing problem. Okay, so the problem's not in here. The problem is with how I oh, of course. Yeah, so the shape of, so if I run ellipse 1, 3, or 1, 4, okay, here, this is what's going on. If I run ellipse 1, 3, it's in the shape of this, the map shape of my data, but I forgot to, for regular polygon, I need to do this regular polygon points, and then define regular polygon is Rn of polygon 2D of regular polygon points of Rn, like that. That should now work. If I save this and then save this, I should hopefully see that working. No way. Still unmatched delimiter. Oh, okay, well that's not what I thought then. I mean, that's one problem, maybe there are others. Okay, let's do this and this. Does this at least produce a correctly shaped data structure for me? Regular polygon of, let's do radius 2, size 6. Okay, so I have nodes, edges, faces. And if I extrude that 2D thing by 5, that produces the right thing there. Okay, so let me walk this thing back a step for a minute and see if I go back to cylinder, will that actually render? Let me find out. Okay, that does. Why would that be? Let's get rid of, let's comment out the oval and bring the hex back in. It's peculiar to me. Okay, so that's not working. So it's not related to that being commented in or out. That's what have I done? That's correct. Extruding it is also fine, at least theoretically. If I change this, okay, so it is rendering that. So it's something. It's something in the way regular polygon is being generated that's not working properly. Okay, I can work with this. Regular polygon, radius 1, and just do 8. Right, so I have one face, I have 1, 2, 3, 4, 5, 6, 7, 8 edges, and it all looks to be working the way I expect it to. What? It's just the name? I don't understand that at all. X hex. X hex. If this gives an error, that's weird and I don't understand it. Okay, little note for myself here. Transform X in the parser weirdly not working when I have something defined with symbol X hex. What's going on? I'll be right back. I have to check something again for a minute. My apologies, but gotta take care of something for a second. Back at it again. Okay, what's wrong now? Is hex a function? I don't understand at all. But okay, that'll be something to troubleshoot as I go. Right, see, that worked, and all I changed was the name. So I don't know. Ugh. Excuse me. Feel free to talk in the chat, by the way, hey? If anyone's interested, anyone wants to chat, you go right ahead. Ask questions, anything like that. If you want to just sit and watch too, that is also totally fine. If for some reason you're watching this when it's not live on my YouTube channel or on just on Twitch with a past VOD or something, thanks, I really appreciate that. If you're so inclined, you can go ahead and follow and just keep an eye on things as I keep this stream growing and evolving. I'm really keen to keep it going, so any interaction, any feedback, anything like that is super appreciated. And if you're just watching, awesome. I appreciate that. Okay, so that's working. If I do 4 on a regular polygon, it's a square, but it's a diamond, which makes complete sense based on how I assume the way I wrote this, the first vertex of the regular polygon is always going to be on at 0 rotation, so it'll always be along the x-axis, so it's always here. And then if it were rotated by a half angle, it would be oriented so the x-axis would go through the middle of the first edge. But that's not how I built this, so that it's that way makes total sense. 3 should still work, and obviously if I put it at 2 it will break, so I will need to make a few people have mentioned spec or static typing in general. With these kinds of functions where it'll legitimately break if I don't give it the right edge count, so at least 3, it might make sense to add in some validation so that you cannot run a function with the wrong, like with literally incorrect inputs. This also, like, you can't have 3.5 faces. That doesn't make any sense. So that's where it starts to make a lot of sense to put in some constraints on the inputs that you provide into functions. So spec, I'm pretty sure, is a really good, like, it's the official as it can get. It's like one of the main Clojure libraries for that kind of stuff, so I'll probably have to learn that effectively soon. Okay, what did I just do? Oh yeah. So one thing that is kind of interesting, I guess you could say, is my regular polygon function at high enough face counts, it's gonna look exactly like a cylinder, because the logic I used for a circle is that it's a discretization of a continuous parametric curve, And so visually it'll look exactly the same. And you could cheat your way to a cylinder like I've just done here by just doing a polygon, a regular polygon with a really high face count. Like if I double this to 100 and rebuild, this will look even more circular, right? There's a point of diminishing returns, and that's a huge amount of faces and stuff, so that's a little impractical. Okay, so what I want to try, or what I want to think through for a moment, is the idea of making a bolt. So this will be kind of the first more advanced shape. I don't think I've fixed CAD view to work on lists yet. Oops, gone and move. Let's move it on. Let's move it 2, like that. Oh, move list. I don't see. I think this will break. I don't think I don't think I've dealt with this properly yet. Yeah. Yeah, okay, so that'll be fine for right now. I don't need to use this. If I instead do, CAD view absolutely has to be fixed to handle assembly items, but for the time being, I will worry about that. For the time being, what I would rather do is use underneath here a figure view and manually and just do it a little more directly, right? So what I can do, 500, 300, 20, the figure name is bolt, and inside here I want to draw edges recursive on list, and this is where I do gone and move cylinder like that. Oh, I have to try something. Comment that out before I go too far with it. I think I may have used the wrong function for a minute, so I'm gonna just sanity check for a minute here. List hexagon, which instead of extruding 5, I'll extrude 1. So I've got here cylinder. Let's actually make the scale 10. We'll make the radius of this 4. No, we'll do 3. And the radius of this cylinder we'll do is 1, and the extrude of that is 6. That seems reasonable. And here we'll do move, the 3D move, the cylinder by some amount where it's 0, 0, 0, but along X we'll do it 1. And we'll see if this will render the way I think, or if it won't. Yeah, I think it's not going to work. Right. Okay. No problem. If I now get rid of that, just make this gone there. Let's get back to a point that I know is rendering okay. Yep. So we've got the hex part of, it's extruded by 2 of the bolt that I'm working on. That looks good. But in a separate view down here, I want to recursively draw this and see if that'll work. Yeah. Okay, we got something. We're going somewhere. This has to move 2, and this draw edges, I have to move in the 2D context. Let's move it 10 and 5. Oop. Ugh. Because this isn't in this file that I'm editing now is a, like, I saved it as a markdown file because the text inside it is just markdown, but the code snippets inside it are obviously in Clojure, but my Emacs is in fundamental mode. It's not in any mode that will properly highlight or tab mixtures of prose with Clojure. So all the indenting and parentheses matching and stuff is all out of whack in this file, but it's pretty much fine in this one. So that's an obvious workflow improvement that I can make eventually. All right, let's this bolt is a work in progress a little bit here, but let me try to rotate it into a view that I'm happy with. I think that'll work. No. Oh, I haven't updated the recursive function to handle. Yeah, that's right. Instead, I have to do a goof. Okay, draw edges recursive of map orient ISO onto the list that is these things. Right? And that should work in theory. In theory. Yes, it does. Okay. So this is a weird looking bolt. It's also, in terms of actual like CAD 3D data structures, it's not right because the cylinder and the hex are still, they're two separate solids, but you would want to create an actual bolt as a single solid, right? So I would need to do a union of this with this. If I could interact with this and select the face, for example, the true face of this, the underside of the bolt, would be a hex with a hole cut out, basically. That would be the single face. It would look like a donut with a hex side. But as I've done this, I've just made a list of two different shapes. So this face, the face on the shaft side of the bolt of the hex, man, that's a confusing sentence. That face does not have the correct cutout edge. So that's incorrect, and so I'm wondering if there's a good way for me to work on unioning, like to make a union of those. And that was also another reason why I wanted to start working on this. Pardon me, Multipath Sketches. But before I go there, I need to briefly think about the idea of merging two different object maps into one. And that might be possible, and it might be really confusing. But I have an idea. I have a little bit of an idea that might work. So I cannot just directly merge the two, and the reason for that is because if I have, let me see, if I extrude, pardon me, if I extrude a regular polygon that of 2 by 6, sure. If I extrude it by 2, I have a 3D shape here. But if I look at that shape's, the nodes have positional data in them, right? That's fine and good. But the edges of this are connected implicitly by the first edge is from the the 0th node, so the first node in the list and the second node in the list. If I merge the maps together directly, I'm going to overwrite some edges, and I'm going to mismatch nodes with edges from, like, it'll just completely jumble the face and edge definitions of things. And I can maybe I could show that by doing, if I do here, how does merge work again? Merge. Yeah, okay. B1, if I do A1, B1, I'll get a map that's B1, A2, yeah. So, if I just do a merge of let me show an example here. If I orient isometrically is ISO, the merge of gone and move of cylinder by 200, think that'll still render. Yeah. It's gonna be, it doesn't even render sensibly. So it's not even rendering for me. Ugh. Inspect. Let's see here. Something went weird. Right? See, it didn't even, it gave an error. Or let's try, let me just double check one final thing here. Oh, I may have been off. Oop. That's right. There. Let's see if I can get it to render. No, still no. Okay, so it's clearly not working, right? It's not working properly. So what I would want to do is first, let me see. Merge with, is that a thing? Let's try that. No. Okay. So let me revert this back to a state where something's visible on the where something looks nice. And I'll work on a bit of a merge situation for a minute. Okay, so that's the shape we can. This is kind of, I mean, the bolt is poorly proportioned. It doesn't make any sense, but I'll get there. What I do want to try do inside this chunk thing here, I've got the concept of assemble, which I need to improve here. So assemble two objects. This is old actually. So what I want is define so this is not assembling, this is a union. So join assemble. Sure. No, we'll just do union. We'll just call it union directly. Define union, right, is going to be shape A and shape B. And it's going to be some kind of weird map merging sort of thing where I have to shuffle around the edges and the faces definitions of the second shape, right? So basically let A nodes be nodes from A, A nodes, A edges, right, be edges of A faces is the same faces of A, and then the same thing, the same sets for B, and those are the parts I have to play around with. B, 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 B. So, unioned nodes is actually just going to be concatenate nodes A with nodes B. I think that's right. A nodes, B nodes. So I'll test that out for a moment. U nodes. If I, concat, I need to spell it right. Concatenate there. Save this. Pop it into the REPL. Okay, so we've got union. So let me think for a moment about so the reality of this function is actually even more complicated because I'm not going to be considering I am going to call it join because it's not a true union. Like union, join takes two shapes, two shapes or solids, two solids, and merges them into one solid. Unlike union, join does not calculate new intersections, trims, extensions, etc. It is a dumb union. As such, this is just a starting point, not a final this is just a starting point, not a fully useful function. There we go. Okay, that's fine. So here, if I run this, let me run this join function on, if I define some a test shape ASDF as extrude of what's a really simple shape? Oh, let me do regular polygon with a radius of 1 and sides with 3 sides only, and I'm just going to extrude it by 2. So ASDF is this thing. If I join, so first off, if I count the number of nodes in ASDF, I would expect to see 6, I think. Yes. because it's a triangle that's extruded, so it just doubles the amount of nodes in the shape. But if I join ASDF with itself, right now I'm just showing U nodes. If I count that, should I see 12? Yes, okay. So we're on the right track there. Now that should be the easiest thing. Let me do a sanity check for a moment. Let me do a join of ASDF with move ASDF by -10, -10, -10. So all of the and then let me do, on that, we'll map vval onto everything in the list. So I see just, yeah. Okay, so what I'm checking for is if all of the points from the second shape are after all of the points from the first. So the first 6 points, 1, 2, 3, 4, 5, 6, are very clearly not moved by -10, and then all these ones very clearly are, right? They've got -9, -10, -10. Yeah, okay. So that does mean that when you join the lists of nodes, if you join A and B, the A nodes are in exactly the same position as they were before there was anything joined to it. So in every case, A nodes is fine. It's effectively equivalent. A edges will correctly point to all of the nodes, and A faces will also correctly point to the right indices of the edge list and the node list. The only things that are wrong are B nodes I also don't have to do anything with. It's just a list of nodes, and it's going to be appended onto the list of A. B edges and B faces will have incorrect indice values, so that is what I have to shift. So in order to do that, I can make a little helper function probably called shift indices. And what I can do is how do I want this function to look? Shift indices, should it work on so what I'm thinking is for the B edges thing, for example, all of the indices that it points to are going to be incorrect by the count of A nodes. So all I have to do is shift the values of each of those edges by incrementing their indices, right? So what I'm going to do is assume it takes shift indices is going to take an entity and the shift val. Okay, so it's going to take one of these, and all it's going to do is update the val with the shifted val. So I can actually, I think, use update in the, well, actually, update map key function. That's the map, the key is val, and the function is map v of this might not be easy to understand, but I'll see what happens. Plus, let's imagine I have to shift them by 2. Is that going to work? No. Right, nested lambdas are not allowed. Yeah, I'm not surprised. It is confusing. Function of that worked. Is that how I want it to be? It's a little confusing. Well, okay, let's, well, I'll write it. Let shifter be the function, a function of val, function taking a value v, and then that function is map v of the addition where you do shift val like that. So that's the shifting function, and then all you do is update entity, the entity value with the shifter, and you should be good. So let's try that. So if I do shift indices of the entity that is produced by 0, 0, 0, and I want to shift it by 2, this should return a wrong, it doesn't work. Okay. Right, of course I have to properly map. I didn't use map correctly, v. So that's the function, should work now. If I do that and call it, there we go. So the value in here is 222. So all I have to do is this. B edges would be edges B, but I have to instead map shift indices onto the list of edges B where the shift value is count of A edges. So that's theoretically correct. And B faces would be the same idea. Map shift indices of faces B by the count of A faces. Then updated nodes, union nodes, union edges is just concatenate A edges, B edges, and U faces is the same, concat A faces, B faces. And then all I have to return is the map of these things. Nodes, U nodes, edges, U edges, faces, faces, U faces. There. 1 minute. Okay, so I have this join function that I think will work, and I'm going to run a test like this. Okay, so something went wrong. Don't know how to Don't know where things went wrong. Well, let's run it. Right, so there's still the same problem. Where did I go wrong? Let's do it one little bit at a time here. B edges. Okay, so I've got a problem right away. Oh, yes. Okay, so shift indices has to be, I have to make it a lambda, shift indices of edges of B, right? Map shift indices of whatever entity by the count A edges. And I have to map that function, that lambda, over edges B, like that. So that should produce a list that makes sense. So join ASDF, ASDF. There we go. So that's B edges. Something's going a little goofy here though, right? 10, 11, 11, 12, 12, 10. I have a duplicate here. Maybe that's probably a pre-existing issue actually. If I do edges of ASDF, yeah, I made a note about this before and I haven't fixed it yet. I shall get to it eventually. I also realized these shouldn't be shifted by the count of edges, they should be shifted by the count of A nodes. And then likewise, so then I have to, right? Is that right? Yeah, it would be right. So instead of that, join ASDF, ASDF. Yeah, there we go. That's the correct shift instead. Yep. Okay, so let's fix faces now. Count of A edges instead. I have to map this lambda, shift indices, by the faces of B. There's that. So now that should, now this should be what I'm looking for. Let's see. So if I join ASDF, ASDF, okay, it looks like we have something that makes sense. Now I can try to run it on my other shapes here and see if it'll render the way that I expect it to. So instead of having to do this, what I want to do instead is join gone with this thing. Let's make sure that the parens match, join, orient that whole thing, draw it, move that, yeah. Okay, let me see if this works. No symbol join because I haven't tangled this in. Oh. Copy that. Okay. Let me see if this will work. Wow, I think it actually worked. I'm a little surprised by that, to be completely honest with you. Let's make sure it actually is. Let me adjust this. Instead of 3 being the radius, let's make 2 the radius. Yeah, it's working. Cool. Sweet. All right, we're getting somewhere now. So this actually does mean that if I def crappy bolt as the join of gone and as a join gone and move cylinder of 200 like that, right? Crappy bolt is just a crappy bolt. I should see that work in the CAD view now, I hope. Yes. All right, we are getting somewhere. That is very exciting. Okay, so a join nicely lets me collapse collapse. Okay. It lets me collapse multiple disparate objects into a single object where all the lists are concatenated onto each other and the indices of edges and faces are incremented appropriately. That is pretty exciting. It should mean as well, actually, that draw faces should work like this now. I wonder if it will. I just need to also have inside here the orient ISO. Is that gonna work? It does. I just accidentally transformed it twice, which I don't need to do here. Let's go back, join, oof, what a mess. Some of this stuff is getting a little unruly. Okay, join, draw faces, there we go, move figure. So that should work, and then this should flip the other way. Yeah. So that's, man, I'm happy with that actually. That's different than what I wanted. And in fact, there's still going to be problems because this face, so there is, you won't see it, but the face that's defined by this circle here exists, and it should not exist, because like in a proper union of the two shapes into a single one, there's no such, like, it doesn't make physical sense that there's a face internally there, because the solid volume wouldn't have a face defined there at all. Obviously I still have, like I mentioned earlier, order rendering issues with the order of faces. So this node here, if I drag it down further in the DOM, at some point, yeah, that is rendering more correctly. There's also these jaggies in the corners here because of how My edges are being drawn. There's all little things to improve, but the ideas behind it are actually coming along quite nicely, which I'm excited about. Let me think for a moment about what I could do next. I actually want to see I think this will work. If I do join 2, and then here I do define join as reduce takes a function and then a collection. If I define join as solids is the thing it takes, which is a list, I can do reduce, right? Reduce, it takes a function and a collection. I should be able to reduce with join to the solids. That should work, I think. Of course, if I need to define join 2 like that, and then join is that. If I save that, so without join actually if I do join and solids like that, will that work? Let me zoom out again here. I wonder if that'll work. If I'm thinking of the reduce properly. Looks like it. Okay, so what I should be able to do with this join, I should actually be able to sneak in another, like if I move let's just make another okay, if I make, well, let's do this. That should work. Let's see if it does. It does. Yeah. Okay. All right. That's perfect. Okay, so I have a general join function that can take any number of solids, which is really useful. Now, obviously, like I keep saying, the rendering of this is not correct yet, but it's a big improvement. And there we go. So the rendering it as a wireframe is always like a nice cheat. Cheat being yeah, it's kind of a cheat, but it works really nicely because the wireframe, you don't have to worry about rendering order of faces or anything, because you could see through everything. All you need is the edges, and you can render them in any order you want, and it'll look correct because you can't tell the depth of the edges anyway. So and of course a wireframe is not it has ambiguity to it, right? So there's reason to want to have a good face rendering, but I'm not doing it right now. Okay, so the next thing, I'm running out of time a little bit, but the next thing I'm going to start to work on is let's split ski this. The concept of the multipath polygons. So that has to be treated a little bit differently, and that is kind of harder to do because I don't have an immediate solution. Okay, so we'll start with box. Could probably delete this box, but I'll leave it there for now. Renderable objects. The idea of an object I got rid of for the time being, so that's okay. So I just have entities. Let me change the fill just as a brief distraction. I'm going to distract myself for a minute, give my brain a bit of a break. I'm going to change the default fill that is being kind of hard-coded into the edges for a minute to something that I think kind of looks nice. This is always a nice color. I like green, and this is this theme is fantastic, the Nord theme, in my opinion. So if I save that and I turn this back to draw faces and just delete this because I don't want it in there anymore. So if I save this, I should see theoretically nice green colors here. Yeah, okay. And I closed it a little prematurely. Let me go back, Nord theme, and I do want to also change the default color from slate gray of the outline to this, because why not? Why not? Go there, save that. Oh, and I have to rebuild it. I should see these change color to be quite a bit darker. Oh, yes, not here because of some reason. Must have done something silly with fill. Well, a problem I will work on another day. fine. So the idea of sketches. A sketch can be any set of a sketch right. ASDF is just a 2D drawing, right? Yeah, it is. Yeah. No, I'm incorrect. It is in fact a 3D thing, because let me just redefine. Let me get a 2D shape to start working with instead. So ASDF is a regular polygon of radius 1 and 3 edges, so it's a triangle. So now ASDF is just a 2D thing. What I want, oh, this looks ugly. That's okay. So I need a new concept of well, actually, do I need a new concept of anything? If I draw That's not what I need. Oh boy. I'm wondering what really has to change in order to have holes in a polygon. Like, because the nodes and edges don't actually care about anything. The only thing that kind of matters to properly draw a thing like that is the definition of faces. So I wanna try fabricate a shape that I can test this out with. So I should be able to. Okay, if ASDF, right, is just a 2D thing. Does join work on 2D things, or did I break something? No, that should work. Okay, so I'm gonna define ASDF to be ASDF sketch, sorry, to be the join of a shape that has, let's make it a regular polygon. The outside has a radius of 5 and 4 edges, and the inside has a regular polygon of radius 1.5 with 4 edges. ASDF sketch should still work, and I should be able to extrude that. ASDF sketch by 4. Okay, so that all seems to work. So let me now, if I have this figure here doing a draw faces of that, let me get that out of the way now. Since I have the idea of a crappy bolt with a join just fine here, I can pretty comfortably delete this join here. So what I want to do instead is draw faces of ASDF, but I have to define it in this file, def ASDF as the extrude of the sketch, which is made up of a join, regular polygon 5, 4, regular polygon 1.5, 4, and it's extruded 4, doesn't matter. Okay, that's ASDF. So if I draw faces of that, well, let's start with draw edges of that. Is that going to work? Let's find out. It would appear that there are errors. Of course, I've got a bit of a clash of naming here. Foo, why not? I'll call it foo. That is something weird looking. But it's not necessarily a bad thing. I'm confused as to what orientation of this I'm looking at. So I normally I normally rotate the extrude. Rotate it. Rotate it 90, 90, 0. See if that gives me a better orientation. Can I make sense of this? Almost. Okay, so it's almost working, but it's clearly not correct, but that's okay. I do wonder if I swap the extrudes around actually. So I'm extruding it by 4 here. If I instead do the extrude piecewise, right? Instead of on the join of the sketches, extrude this polygon and extrude this polygon, will I get a different result? Extrude it by 4, join it, extrude this one by 4, join it, and then rotate that bad boy around. Always with the typos. That's fine. Yeah, okay. So I'm on the right track, but joining a sketch obviously has a little bit of problem. It has a few problems associated with it. If I orient this by front, by the way, it should look more correct. or it might be easier. Yeah, okay. So, right, in theory, I've got what I want. I have just one face, right, where the this would be colored in and this would not be colored in. But if I draw faces of this, the entire thing is going to be green. It's not going to work. Yeah. So what I want in theory is this inner one here to not have shape to it. And in order to do that, I need to change up how I actually do this, which is a bit of a shame because it's more work than I wanted to do. But I do need to do it, so maybe there's no way around it, right? Just gotta go through it. But I do wanna, okay, if I draw edges of that, it should look fine by the front orientation. But what I want is to be able to join these before, right? I want to join it, and then I want to extrude the whole thing because that would be pretty cool. And I'm not totally sure why that wouldn't work the way I expect. Extrude 4. Okay, join those two things as sketches. Extrude that single sketch so it's a 3D thing, and then rotate that thing to get the orientation that I want, and then show me the front face of it. Okay, so I've got two things kind of crossed there. If I orient front, oh, wait a minute. What if I just for a little bit of convenience here, do CAD view 720 by 720 by scale 20, yeah, of foo. Let's give that a shot. That way I don't have to fiddle around with orientations. I get all of them for free. So what is happening here? I have a problem with the order of nodes a little bit here. I've got two edges being incorrectly drawn and no edge being correctly drawn here. So something's going a little fishy there. And the reason for that, it doesn't come to mind right away. I have in here defined ASDF, right? ASDF sketch. Count nodes of ASDF sketch 8. That makes sense because the ASDF sketch is exactly the same as this. I've joined a regular polygon and another regular polygon. So it'll look like this. It'll look like this diamond with the hole in it. These edges are crisscrossed, but that's why is that? if I think about joining these two things, I have an incorrect. If I pull the faces from ASDF sketch, come on. Oh, faces, ASDF sketch. Show me that. I have two faces. This, which is actually incorrect in this case. I should instead, what I would expect to see, because I'm doing a join on these and I want it to be a whole, I want the inner edge to be part of the definition, the inner edges, I should say, to be part of the definition of this face. So what I should see instead is this assoc into the ASDF sketch, the key faces, and then the value I want to associate into it is entity, and I'm going to manually put it in here, is 0, 1, 2, 3, 4, 5, 6, 7. It should be just a single face like that. So that if I take faces from that, no, just so I can see a little more concisely here. Oof. So right there, I have faces as just one face, and it's defined completely by every single one of these edges. 0, 1, 2, 3, 4, 5, 6, 7. Right. So then, let me try to fabricate. Let me make a sketch that def-foo sketch, okay, is exactly this. It's the join of those things, but associated in, yeah, let's do it like this. Assoc join regular polygon 5, 4 and regular polygon 1.5, 4, join, associating to that faces a new thing. Man, this is getting confusing because the indentation's all weird. Okay, associating to that exactly what I've already done. I'm just going to manually type it because that'll be okay. Entity 0, 1, 2, 3, 4. 5, 0, 4, 5, 6, 7. Get rid of that. So that's foo sketch, and then foo itself will just be the extrusion of foo sketch by 4. Let's see if that'll work. It actually did render, which is kind of cool. But now, just out of a bit of curiosity here, let me open up this again, this figure, and draw faces of that. What weirdness will happen? Okay. we're kind of getting onto something here. Oops. Let's orient it ISO. That looks like some weird n-dimensional. This just looked confusing. Right, so let me inspect this. Let me just start deleting faces here. Right, see, this is extremely confusing and not helpful. So I have to work on things a little bit. I'm curious, actually. If I go to SVG Polygon, does Polygon let you have inner fill, even, odd? What I'm thinking through for a moment, just for clarity here, since my library just creates SVG anyway, I am wondering what the general approach is for polygons. Polygon points. Okay, let me make a, so I have ASDF sketch here, right? Yes, if I do map val onto nodes of ASDF sketch, okay, I get a list of points. If I run, pull that back up again, if I run Polygon on that, I have a weird sort of points list. Okay, so let me comment that out and put here, yeah, Polygon map val onto foo sketch, nodes of foo sketch. Save that and see if it'll render. So I'm looking here for a new render. Might break. This is why. Map val onto nodes of that whole thing. There. That should work. Okay, we're getting somewhere. But I do need to move it into the frame. So let me cut this, undo the move here, comment that one out, paste this here. Oop. Should see that in the frame a little more easily. Hey, okay, that's interesting. Okay, so that's where, so I'm getting a weird problem here, because when I actually join the sketches together, there's an edge order problem, which I hadn't realized before. But now, if I inspect this element, and open up and find its polygon here, fill green, and there was this even odd thing, fill rule even odd. Ah, okay, that is a useful insight. That's something useful that I'll check in a moment. Oops. Alright, I gotta get going soon, about 10 minutes or so, but that was actually pretty useful for me to learn. Let me just make a tiny note in here. Draw faces may be able to use the idea of even, odd, fill approach. SVG polygon fill rule have this feature. Okay. To check my intuition on it though, I'm gonna fix up I'm gonna change this, fix it up for a minute. I'm wondering why that even is why that's actually a problem. Let me see. Count the nodes from this. Is it giving the right number of nodes? Yeah. So it's just messing with my ordering a little bit, which is not good in the sketch environment. Okay. No problem. No problem. something to work on. Always stuff to work on. What if I do this? Will it end up being the same, or will it be different? It's like the edges are using the, like, it's just pointing to the first node and last node of the wrong lists, and so it's crossing over. That's something to fix in I don't know. Not sure the right way to solve that one yet. But for the time being, I'll just have to be okay with that. So there's one other thing I can do. I can make a foo sketch 2, which will just be instead of this, if I do regular polygon 5, 4 like that, yeah. So map val onto, yeah, I can actually do this. Instead of doing the join, I can just do concat nodes of regular polygon five, 4, concat that with the nodes of regular polygon 1.54. And that should work. So I don't have any weirdness going on with a join, it just concats things directly. Did it not make a single difference? What am I doing wrong here? Let me see, what does this return? If I do that, I get a mess in my REPL. Where's my REPL? Oops. Okay, so I get a list of 1, 2, 3, 4, 5, 6, 7, 8 points. Is it because 5, 0, and this goes immediately to 3, 5. Why is that? No, that seems... Oh, it's not 3, 5. Yeah, okay, so it goes from here. This is the second point, third point, fourth point, Oh. Okay, let's imagine it's like this. First point, second point, third point, fourth point. Fifth point is, yeah, okay, that's the, so polygon, okay, it's not, right, okay. Can I make yeah, okay. So a polygon doesn't have a concept built in for inner and outer or anything like that. The only thing even odd does is when a polygon like crosses over itself like this, it like negates for that. But that's not a hole, that's just the path that crosses over itself that causes that to happen. So that's not correct for what I need. Is there a SVG polyline? Does polyline is for open lines, path. Okay, so path maybe can have internal yeah, complexity involved in drawing paths. I understand. Smooth, this, close path. I wonder if I do have to path with holes, an SVG rectangle. Can you do that? Yeah, path pointer events to none. Oh no, this is not what I'm talking about. Okay, here, fill rule even odd. This example, draw an outer shape and an inner shape, the holes, in different direction. Okay, so path is, yeah, okay, path would be how I can achieve this. That's actually pretty useful. For holes in SVG, use path. Generate path lines per loop. Need to have concept of closed loops now in sketches, which can be fine, but now the complexity is increasing with the data structure of all this stuff. But that's just the way it's going to be, because drawing things is kind of complex anyway, so I understand why that would need to happen. So let's see this example from the SVG spec for a moment. Is that, oh yeah. Right, so this path, as an example, copy. Can I copy it? Really? Edit. There's something. Okay. So that's a starting point that can be pretty useful. And on that note, I'm spinning my wheels now, so I am going to get going for the day. Thanks for tuning in. If you're watching this later, thanks. I appreciate that too. I'll be back again tomorrow at 12:30. I really enjoyed doing this, so for the month of June, it's every day. After the month of June, I'll have a bit of an idea about, my ability to keep and improve the quality of the stream relative to how much time I need to spend not streaming, if that makes any sense. So since this is all experimental, it's still a learning process for me. I'm really excited to keep it up. So thanks for views, thanks for chats at any time, thanks for comments, all that stuff. Hope everyone is having a good one, and I will be back here tomorrow.